Okay, so for today's question, we're going to do it's 2016 higher level question C2. So 2016. So what it is hyperboloid of revolution. It's actually just half of a one. We're asked to do a front view, a top view, and we're asked to do an end view. We're also asked to determine the position of the focal points. You'll see this marked in the solutions on examinations.e, but we're not going to get to that today. So we're just going to basically do the first two bits there. So the scale is 1:100, which makes it easy. So 12 meters will be 120 millimeters, 10 meters will be 100 millimeters, or they're the same as what they'd be in centimeters. So we're going to start off maybe with elevation just to make sure that we've spaced that it fits. So it's 13 millimeters or 130 millimeters high, so come down to about 140. Now I didn't pre-print this page, so we're just going to start off now about 140 from the edge, and we're going to draw like so. Okay, now if it was hyperboloid revolution, I'd always start with the plan if they're in circles, assuming looking down on top of it that way, and project up. So what we're going to do is draw crosshairs first in plan view. So we know that the biggest diameter is 12 meters. So the half of that would be a radius would be 60. So I'm going to come down about 70 from that line, my ground line, just to make sure it fits. And again, because there's an end view on it as well, I want to come in about, well, I'll come in about 80, okay? Maybe a little bit more actually, just so that it looks a little bit more central. Maybe come in about 100. Okay, so that looks fine. So I'll draw my crosshairs like so. Okay, so I'm going to set my compass to 60. Now there's two ways I could do this. The first way that I could do it is I could set it between the points. The second way that I could do it is I could just mark 60 millimeters there. So we know the other one is half of 50, which is 25. So I just put those two dots. That one there was a mistake, just in case you're wondering what that's about. So I'm actually going to use a blue to draw these, because when I look at my plan here or my question, I can see that they're two heavy lines. I'm actually maybe I'll do a blue for the inside one and a pink for the outside one, because there is this V shape that cuts out of it. Okay, so blue for heavy. So we'll start with so. Okay, so I'm happy enough with that. And let me just keep this one pink so that it'll be light, just because we're not sure where the, well, I could actually draw so that it's heavy. The reason I'm trying to do this heavy at the start is just because it's harder to get it to come back and hit the lines exactly at the end. So what I could do is draw two light lines down here, because I can see from this question that the width where this V shape starts is basically the same width here. So I'm going to draw those down. I'll go back to putting the blue into my compass. Okay, let me tighten that up. Okay, so start here, bring it round and draw this. Now I'm not going to draw the V at the minute, and the reason is because I don't want to confuse the main bit, which has asked me to do the hyperboloid of revolution. I'm going to draw this V down here. So I'm just going to start to bring those up. So I'm going to use maybe a slightly different color line just to bring them up for projection. So I'm going to just use a light green. So again, I'm using this just to show that they're light. Now, what I've also said in previous questions is don't bring up the center line for the minute. And the reason for that is that I don't want to get confused where V1 and V2 is. I want to make two outer rectangles. So we know that basically the hyperboloid of revolution is 10 high up to the throat. So 10 or centimeters, 10 meters, 100 millimeters. Okay, so just try and straighten that up a small bit. Okay, so I'm happy enough with that. I've drawn my two rectangles. So if some of you are looking this up online, you'll see that there's an alternative method. Some people use a rotation method in order to solve a hyperboloid of revolution. The students I have tend to like this method because I think it's one of the easier ways to teach them it. Okay, both methods are perfectly acceptable for the exam. I'm just going to mark V1 and V2 there. Okay, so we have this here, and this is 100, and that divides easily by 5. So we're going to mark every 20 millimeters apart. So 2, 4, 6, 8. Okay, so I have my points there. The next thing I have to check is, well, what do I have here? So this was 25 and 60. Now, I would probably draw just a division line method here, even though technically I shouldn't have to, because 35 does divide equally. But I'm just going to draw it here, just to show the examiner that I can do it. I'm just going to do it on one side, just to prove the point that it can be done. And then I'm going to slide it along using my slide and set square method. Okay, so that should give us gaps of 7 apart. Mine might be a slight bit off just because it takes my markers. But just to prove that I can do it, I'm just going to do it there. And that'll be enough to prove it. So I'm going to get my red pen now and I'll mark. So if I call the corner 0, I don't draw one from that. So 1, 2, 3, 4, 1, 2, 3, 4. So hopefully they can be seen. So I'm just going to use a red maybe to draw these. Now again, if I try to draw these to V1 and I try to draw 4 from there to V2, you should see, well, that one won't meet that one, so it must be the wrong way around. So it must be this way. Okay, so and draw like so. Okay, so we're happy enough with that. And we do the same here. So we're 1 and 1 crossed, gives me a point. Okay, so these markers are a little bit thick, but if I was drawing with the thinner pens that I have, it would be unlikely that you'd see them on the video. It'd be quite difficult. Okay, so I'll mark dots there where 1 and 1 cross, 2 and 2 cross, and I'll sketch it in. So it's a very slender curve at the start, and it flares off. Okay, and we're happy with that, and there's nothing to finish. Now I'll just point this out just so, because we're going to get this in a second. When I go do this side, I'm not going to heavy it in because there is, you can see there's a little bit of hidden detail there. This edge here is slightly flat, and then there's a bit of a curve. So just to point that out at this stage so we don't go too far. Okay, so what I'm going to do is do the opposite on the other side, or I can use the mirror method. So I might use, no, I won't use the mirror method. I'll do the opposite side. So I'll just mark these here. So as I said, this was 35, so I'm not going to actually do the division line method. I've shown that I can do it on the bottom. And the same here. I'm going to go 20, 40, 60, and 80. So these ones will go the opposite way, so these will go to V1. Okay. And if you did them the wrong way around and you copped it on the day, don't be afraid to draw them across. Just be careful with which ones you intersect, that you don't get confused. So if you did them the wrong way, just continue on. You don't need to start the question again, but just be very careful which one joins to which. So again, I'd always write my numbers on them: 1, 2, 3, 4, 1, 2, 3, 4. So 1 and 1 cross, 2 and 2 cross, 3 and 3 cross, 4 and 4 cross. Okay, so overall I'm happy with that. And again, the I suppose the reason for the question is to show that you can do that. So that's quite well done so far. So we have this top bit here at the top. Now they show a hidden detail line, while technically this is actually of no use, and I'm not sure why exactly it's shown, except for to show that it would continue on, that you could have. So because it's shown, I would definitely use a mirror method to put that in. But the first thing I'm going to do is look at this. So this is basically a right angle triangle. So we know that it's 30 millimeters up high. So I'm going to measure up 30 and draw a light line across, and we'll get that triangle in there first. Okay, so I'll measure up 30, draw a light line across, and then we know that this comes up at a right angle to meet it. So make sure that line is there, and this goes down like so. Okay, and they put in the symbol, so we may as well put in the symbol to show that that's a right angle. Okay, so they did show this as a hidden detail, so I'd always show everything that they show in the paper. So what I'm going to do is I'm going to take this point here, and I'm going to project it up, and this point here, and I'm going to project it up, and hopefully I left enough space. That was the one thing that I didn't really think about. I can do it an alternative way anyways if I didn't, but hopefully I left enough space. So what I'm going to do is I'm going to take my compass, and I'm going to set this distance. Okay, so that worked. And this one. Now I could also get the one from where 2 and 2 cross and put that on. Okay, so there's one point. and there's 2. But really what I need is this exact point here. So what I'm going to do is I'm going to come down 30. I might use an orange just so that it stands out a bit. So 10 minus 30 is 70. And I just want to draw that over to meet that. And that point there should be perfectly symmetrical. So that should be above there. Now again, the thickness of my markers isn't exactly helping, but you should be able to get the gist of it. Okay, so there's my hidden detail curve. Okay, and I'll do the same on the other side. So again, I'll bring up these 2. I should have probably done them at the same time, just to make my life easy. And the reason I would do this, even though somebody would say, well, it's not necessarily needed. If it's shown in the question, there is a chance that they'll decide that that would be worth marks. So bring that up. There's my finishing point. Take my compass again and set these points. And as I said, if I was smart, I would have done both at the same time, because it would have made my life easier, because it would have been quicker. But regardless, the method is the same. So there's my 3 dots, and I'll draw a little bit of a dashed line there. Okay, because that's what they show. So if I look at my elevation, I'm still missing something. Well, I'm actually missing 2 things, but the main thing that I'm missing first is the entrance. So what I'm going to do is I'm going to come back to the plan view. So this V shape of an entrance is based on this. Okay, I don't know if it says that in the question. Draw the given plan, project an end view. Supportive views each tower. Doesn't really say that, but you can see it here. You can see that basically if you take your set square, that will line up with that point. That point there will line up with that point. And also if you brought, let's see, that point there up, you'll see that that hits there. So again, you can balance this against this just to see where it is. So you can see here again, they have this little right angle symbol here. So I have these down below. What I'm going to do is draw them in an orange just so we see. We're going to bring it out that it touches it at a tangent. Okay, so this here is at 90 degrees from the center. So again, I'll mark that like so. And what I'll do is I'll pick the same point on the other side. Okay, and again, as I said, I'd always mark in all of what they show me, just to make sure. Oh, there's my right angle there. So these are basically the entrance. So what I'm going to do is I'm going to draw this in like so. Now there is an alternative way of doing it, and the alternative way of doing it or getting this exact point is you can see that this touches this circle, or it touches at the height 60 millimeters up, excuse me, right? So if I come up 60 millimeters for one of these, and I'm going to draw these rings, hopefully they'll show up in this purple. Okay, so that ring there is basically has to be shown in plan, and that's where that point should end up. So I'm going to bring down that. I'm going to set my compass, and hopefully, if I was accurate, they should all be proven. Oops, my compass sort of can move around a bit, and that I accidentally poked it a little bit too large. But you'll see that that works out like so as well. Okay, so that's basically the plan view if we were to cut off that there. So I suppose I'll do the circles first, and I'll come back then to the entrance here. Although I could probably, actually can just complete the entrance now. If I bring up these points here, which happen to be there, and I bring up my center point now. So I left the center line until now. Now I'll extend it the whole way up again because it's showing the whole way up on the thing. But basically that point there will join to there and will join to there. So we have our entrance, right? Now, one thing that they said here, did they say a series of supporting towers? They don't actually say it, but I know from looking at the solution is these bits here, and you can see them here, are actually markings on the actual structure is that's holding up the object. So it would be important that I would draw them in. So while there is an alternative method that uses these purple circles for rotations in order to show how to get this curve here, we can also would be expected to put them in. Okay, so while we didn't use that method, we could still, because these are, I don't know, they could be supporting steel columns or rings that are basically put around it. So it's important that I draw them in. So from all my marks here, I'm going to draw a line straight across. So, because we were showing that they're even, so there's 1 from 2 across. That doesn't go through. Well, actually, they do show it going through, so I must be able to see through the object. I must be able to see it from the back. Right. Same here. Same here. So just be careful. It's the 4 that you're bringing across. It's not this point. And then we have this one on top. And that's it. Okay. So that one there will be this one here. That's already the blue one. And what I'll do is I'll set each distance from here and draw it in plan. Now I could alternatively just do like I did there and bring down that point. So I'll show that for the last one. Okay, so hopefully these work out okay, because I poked my center a little bit large. Okay, and lastly, just to show you an alternative way, very simple alternative way, is you could just also bring down this point here, mark it here, and then use that. So that one is a full circle. The rest of them are stopped by the entrance. Okay, so overall I think I'm pretty happy with that. I'm taking my question. I'm just having a look. Did I forget anything? The only thing I'm going to do is, just in case, I'm going to extend those on, and I have them done. Okay, so again, just in case they're being particular, they're technically generators of the hyperboloid, but they're sort of tilted towards the front of us. So we just extend them on just to make sure, in case they would have expected. That's a different alternative way. So there's basically 3 typical ways of doing this question. So I have my front view done, I have my top view done. So I now need to do my end view. So my end view for the main part is exactly the same. So there's 2 or 3 potential ways of doing it. The first way you could do it is you could just literally do exactly the same method as I did here. I'll bring this across. Now I'm just going to bring up this point just to make it exactly the same width. Okay, and that'll allow me to project up my end view, or sorry, this into the end view when I need to get the straight point. So, but other than that, I'm gonna draw the exact same. So we know the width was 120, and that means our center point is 60, and then we know that these are 35 in from either side. Okay, so one method you could do is draw your rectangle again. What I'm actually going to do is I'm just going to use the center line and then take the distances from here and translate them across, okay, and use the mirror method. So again, they use a purple line for it, but I'm literally just going to draw a series of light green lines first, just to line it up, and I'll go over them with the purple after. Okay, so I may not be far enough on some of them, but I can figure them out at a later stage. So I'm just going to take this distance here, and I'll mark it off like so. So redoing the exact same method as you did here is also perfectly acceptable, but this is probably a bit quicker. Alright, so there's 2 other typical methods that you could use: the generator method, or what would you call it, rotation method. The only thing I would say is make sure that the examiner can see the marks that you've left. So just to be accurate, I'm just going to make sure that this one is 25 from either side. Okay, so that one's probably a more important point. So the throat should still be 50. Okay, and we'll have a look at the ellipse. So yeah, no, they're still straight lines. Okay, so what I'm going to do now is basically I'm going to sketch this in and bring that one, draw the purple lines across. Okay, and this side here doesn't change, so I'm going to sketch in this one as is. Okay, now this one here is the front. So basically, if I was walking through, this is the entrance. I can walk into the building. I don't know, is there an opening door of some sort there, or is it just an entrance that you can walk in that's permanently open? But that starts from there, right? So basically, I can do this heavy from here to here, but it doesn't curve out. That's basically the hidden detail bit that they show. So we're going to draw that down from there as hidden detail. So hopefully that shows up on the green. And now I need a point here. So how do I get that point? Well, that's where it would finish. So all I need to do is bring this over to my common line. I'll call this here that. I'll bring this up at 45. And that was why it was important that I kept it at the exact same distance. Okay? So hopefully that shows up that it's not a massive difference, but there is a little bit in it. And again, this would be a straight line rather than a curve. Okay, that would be a straight bit of steel. So that's that done, except for this bit here, which has the ellipse. So if you imagine this is a cylinder, basically, that's sitting on top, and it's cut by angle, right, or cut at an angle. So you can see it sort of here. So that means that this shape here is going to be an ellipse. So there's a few methods that we could do this, but the simplest method is probably just to use the ellipse method. We know the minor axis and we know the major axis, right? So we complete that bit first. So if we come up, I can just bring this across basically. There's my minor axis, and then I'll have to split that in half. So half of 30 is 15. If you wanted to be particular, you could bisect it, right? And there is my, let's bring up that point. Well, actually, I can bring them up heavy because they're straight. I can actually bring them up, and that's the two lines of this part here brought up. Now I will come back and finish off these two little bits of layers there. So to draw an ellipse, what do I need to do? I need to draw two semicircles. Okay. So again, this is the most typical method for drawing it. There is a few other alternatives. So I'm going to draw one distance of the major axis, one at the distance of the minor axis. Okay, and then I'll split it into 60 and 30. Okay. There's my 30 degrees gone both ways. Now, if you're tight for time, you probably could just get away with doing a 45 degree one because it's not a very big ellipse, but we have a little bit of time, so we get this in. So again, these ones here will come down, and this here will come out to meet it. So again, hopefully this comes out okay because my markers are a little bit thick. Okay, so I'm assuming that should be seeable enough. So I'll just sketch in this bit here. Okay, now again, I could use a mirror method, but I'm just going to repeat the method for each side. So they'll come down, these ones here will come up. So again, by doing all the vertical ones in one go, it makes life a little bit quicker. But some students like to do it quadrant by quadrant, particularly if it's a while since they've done this. So I have my various points. I'll just zoom in a small bit on that. Okay, so let's just be a little bit more stable, and we just dot our various points so that we know what we're connecting, and we'll sketch. Okay, so overall I'm quite happy with that. I haven't part C done, but the only thing that I still have to do, mine looks a little bit pointy again, it's just because of the thickness of the markers, is just in case they're particular, they do show this in hidden detail for some reason. So what we'll do is we'll just transfer these points here across. Now we can do it a slightly quicker way, can we? No, we can't really. I thought we'd be able to do it a slightly quicker way. We can't really. So what we'll do is we will bring these heights across. Okay, and then we have the top one, and we'll just take our compass then and we'll transfer the widths. So I'm hoping I have them roughly in the right spot. So this width here we'll do for the bottom one. So that's that point. I'll just be careful, it's the bottom sort of mark there. So I'll just put a blue dot on it. This one here is this one. And again, I want the examiner to see my compass marks so that he knows that I used an appropriate method for it. And this bit here is the last point. Okay, so I'm just going to draw it in and maybe just a darker green so that it shows up because I used a lighter green. No. Be a little bit off with that one, so I'll come back and check that one, but overall I'm quite happy with that. There's my question. I'll just zoom out again, and again what I should be doing is double checking by basically doing spot the difference and checking have you both of them matching. So as I said, we'll do C in a separate question, but overall that looks quite good.